Alright, so let's get started. So this is another precautionary measure. This has a band inside. So that is for repelling the mosquitoes. So you have that mosquito killer there, that lamp right next to you, and once you put this, at least it will help you avoid some of the mosquitoes whom you want to avoid. And once before you go, you can just put it back in the pouch and then okay. Don't go by the smell. It is not supposed to smell good or bad. It is just supposed to keep the mosquitoes away. Alright, so what are we going to learn today? Did anybody get a chance to see what we have in the topic? Anyway, don't worry about it. We are still in the last lap of conic sections where we are going to talk about hyperbolas. And if you guys remember, any conic section that we talk about, be it a circle, parabola, ellipse and hyperbola, these are all part of conic sections. So basically the way it works is, you have a cone, you take a plane, cut it. So when you are cutting it horizontally, you will see that this portion that you get here is a circle. So circle is a conic section. I mean, we have covered this in the past. I'm just doing a recap. Similarly, if your plane with which you are trying to intersect the section, if you cut it with a slant, what you will get here, what you will see in the section will be an ellipse. And we talked about the ellipse, we talked about what is the minor and major radius of an ellipse. I know Sahib missed some of the classes, but you can watch the video of those classes and let me know what is bothering you, okay? We talked about the minor and major radius of an ellipse, what is the foci of an ellipse, what is the property of the foci with respect to ellipse that we need to know about. Up to that you guys recall, right? I mean, I hope I'm not convincing myself. Samriddhi, do you recall, beta?
No, I do.
I'm sorry, beta?
I recall it.
Okay. Dave, Vishal, everybody with me?
Yeah.
Okay.
Yes.
So now we are going one step further. We will talk about what is a hyperbola and how is that related or relatable to what we have already learned. So first of all, when you're talking about hyperbola, you're talking about two cones sitting head to head, and then you take a plane to cut it, and then when you cut it, then you try seeing it, you will see that the section that it develops is called a hyperbola, which is nothing but two parabolas opposite to each other. Yeah. So somebody who is smart is called smart. Somebody who is super smart, you can call it hyper smart. So it's a hyper version of the parabola. Yeah. So far relatable. Now, if you extend or expand your visualization skills further and think about it, you will see that, okay, if I have two hyperbolas, if I have two parts of the hyperbola, if I kind of flip one of them and try bringing it down, it becomes like an ellipse. Okay? And again, this is not part of the theory, it is more from a visualization perspective, because I'm trying to connect the dots for you guys. So far, whatever I said, that makes sense, right? If you look at this hyperbola which has two parts, if you flip this and bring it down, it will form an ellipse for us. Do you guys agree? Visually at least? Dave? Samriddhi? Okay? Now, why I'm stressing on this part? Because I'm trying to draw that connection between ellipse and hyperbola. These are not two different things. It's like you have an ellipse, you cut it into two pieces and flip it so that you get a different shape. And which is coming from these two cones being intersected by a plane, vertical plane. Yeah? So now, if you guys try to recall, let me take you guys back into history and teach you guys US history. Yeah? Okay. Bye, Joe. Now, if you remember, if I have a circle, what is the equation of a circle where the center is at the origin of the coordinate plane? It is x squared plus y squared equal to r squared. Yep. This is the equation of the circle where the center of the circle is coinciding with the origin of the coordinate plane. So that means x squared by r squared plus y squared by r squared will be equal to 1. This is with respect to the circle. Yeah. Now when we extended that further and looked at ellipse, we said ellipse is not coming from Mars. This is just an extension of what we know. If I have a circle, if I squeeze it, right? If you are as playful as your teacher, you are squeezing the circle. And that is when the circle becomes like an egg, somewhat similar to an egg, and we call it ellipse. Yeah. So ellipse, egg. There is something in common. Yeah. This will not come in the exam. We just for making it as lightweight, as interesting as we can. So now, with respect to ellipse, in the case of circle, what we know is there is only one radius, meaning any point on the perimeter from the circle, from the center of the circle, is equidistant, and that is called radius. That's what you are seeing here. In case of ellipse, what we saw was there are two radiuses that we come across. One is called the major radius, and one is the minor radius. So if this is how my ellipse is, let's say this one I'm calling as the major radius A, and this one I'm calling as the minor radius B. Same equation I can extend, and this becomes my equation of ellipse. Yeah. So this was my equation of the circle where x squared divided by r squared, y squared divided by r squared, because there was only one type of radius. Here when we have two radiuses, one along the x-axis, one along the y-axis. So I am separating them, and this becomes x squared by a squared plus y squared by b squared equal to 1. This up to this much is okay. Now, and since I was saying that my hyperbola is somewhat closer to ellipse, so basically I have two parts of the hyperbola. When I am bringing them together, so it was like this. What I did was, it was like this. I flipped one of them and it became like an ellipse. So there is one thing for whose x value is becoming positive, or one of the things which had x value positive flipped to the side became negative. So I can extend the same equation and I can say only thing that is happening is position is changing, something from plus becoming minus. This is my equation for the hyperbola. Circle, same radius, ellipse, two different radiuses along x and y axis. Hyperbola, extension of ellipse. So this is my equation for the hyperbola. Or I can, if my hyperbola is aligned along the x-axis, then this. If what if my hyperbola is aligned like this along the y-axis? So if it is y-axis that is predominant, I will say y squared by b squared minus x squared by a squared equal to 1. Now this is getting cryptic. You guys will think, what is going on here? I am kind of forcing you guys to memorize two formulas and say, okay, x squared by a squared plus y squared by b squared equal to 1 was the ellipse, formula for the ellipse. Hyperbola, you are just flipping it. So put a minus here, either this or this, and I'm telling you that, okay, if my x part is positive, that means my hyperbola is aligned along the x-axis. If my y part is positive, then my hyperbola is aligned along the y-axis. And this is a forceful thing that I'm doing right now. But I know there was some amount of stubbornness on my part when I was trying to force you guys to believe this, but I'll come back to this. But so far, anything that has got you, that has got you to get your head scratching so far. Okay. It is supposed to. And if you have not understood something that I have talked about hyperbola, let's not worry about it. I'll do my best to make it easy for you guys. So forget about circle, forget about ellipse. We just try drawing a line between what is ellipse, what is circle, what is hyperbola, and how are they related conceptually. So let's start from here. X squared by a squared plus y squared by b squared equal to 1 is my standard form of the equation for the ellipse. So far, no problem. What I'm saying is, replace this plus with a minus, that becomes your equation for the hyperbola. Okay? One operator, one operand is making a huge difference. Now we'll decode that further. Yeah, Vishal, you have a question?
No, I accepted it.
Okay. Now let's look at this. Let's add some more element of visualization. Do you guys know what are these lines called? If this is my x-axis, this is my y-axis. If I'm trying to draw a curve, what these lines are called? Any idea? Something called asymptote. Yeah? What is asymptote is? Asymptote is more like a boundary. I hope I'm pronouncing it right. What do you call it? Asymptote? Okay.
It's the same.
It's the same thing. Okay. No, you guys have to see. I'm teaching you guys math. You guys have to teach me English. Okay. My English is not as good as you would want it to be. Okay. So asymptote. That's what I'm calling it right now. What is asymptote? When you're talking about any curve or any graph, asymptote is more like a boundary. It says your curve will get very, very, very close to it, but not touch this. It's kind of defining the outer edge. It's like a boundary wall of the house. You will not construct your house on the boundary wall, but you can get as close as you want.
So like the line on the function that the lines that the function will get really close to but never reach.
They will never reach, yes. That's what is called asymptote. So now if you visualize your hyperbola against this asymptote, we'll come to this, okay? If you look at the hyperbola, if it is aligned vertically, your hyperbola will come very, very close to it, but will never touch this, okay? There will be no point on the asymptote that will be common with any point of the hyperbola, any which way, up or down. Or your hyperbola could be vertically aligned like this against the asymptote, or horizontally aligned like this against this asymptote. So I'm just kind of seeding that view of the asymptote for now. Okay? Is that okay so far? I know this topic could be a little loaded compared to the previous one, but we'll take it as we can digest. Okay? Samriddhi, Dev, Praneeth, Vishal, everybody with me so far? Davik, Sahib? Okay. So asymptote I just touched upon from a concept point of view. Now let's look at this nasty formula that we are trying to get used to. Okay? Nasty. Whatever. Okay. So here, this is what I'm saying, that this is the equation for hyperbola. Okay? We don't know how this looks like. Okay? Let's try to break it down. Let's try to get y on one side, everything else on the other side. So y squared by b squared equal to 1 minus x squared by a squared. If this is my equation. Yeah.
Wait, I'm backtracking a little bit, but like, is it the same if it's like not centered on the origin?
Mm-hmm.
Is it the same as the ellipse where it's like x minus h squared? Okay.
Exactly. So see, there's one rule of thumb that you can always keep in mind. Everything goes with the assumption that your center of the shape is coinciding with your center of the coordinate plane. And then if your circle is like this, you'll say, okay, x squared by x squared by r squared plus y squared by r squared equal to 1. That's it. Now, if you move your circle a little bit, and your center of the circle is at h comma k. You will put x minus h, meaning the x coordinate of the center is squared, y minus k, that is y coordinate of the center is squared. This became your equation of the circle. Same thing in the case of ellipse also. Everybody here, everybody here. In the case of ellipse also, if your center is coinciding with the center, center of the coordinate plane, you are saying, okay, x squared by a squared plus y squared by b squared equal to 1. If your this center is here, meaning your ellipse is here, and the coordinates of the center are x comma h comma k, same thing, x minus the x coordinate squared by a squared plus y minus k squared by b squared equal to 1. Okay. Similarly, if you have a hyperbola, and in case of hyperbola the center is here, okay. Yep. So if hyperbola moves here, let's say, and the center comes here with h and k, your equation for the hyperbola will change to x minus h squared by a squared minus y minus k squared by b squared equal to 1. Was that too much of an information? It's very simple. You are assuming that the center of the shape is coinciding with the center of the coordinate plane. If it moves, if the center alone moves to any point, you would subtract the x coordinate from the x part. Subtract.
So you're trying to, it's as if you're resetting it to 0?
Kind of. You're not resetting, you're visualizing that, okay, my x part is moving.
No, like I'm saying, when you subtract h and k, it's as if you're setting it to the origin coordinate to the origin coordinate.
Yes, correct.
Okay.
Yeah. You can look at it from a relative point of view, how far you have moved.
Yes, I'm thinking in Java.
Yeah. Alright. I'll keep Java away. It has been haunting me for last 25 years. So I'll keep Java away from math discussion. But is this okay for you guys so far?
Yeah.
Samriddhi, little better? Okay. So now let's go back to what we were trying to do. So as I was saying that my equation for the hyperbola is x squared by a squared minus y squared by b squared equal to 1. Yeah. Everybody here, trust me, this is going to be very interesting, okay? So need everybody's full attention here. Where a and b are the minor and major radius, if you want to relate it. So here, what we are trying to do, let's find out some relationship between x and y. So y squared by b squared will be equal to 1 minus x squared by a squared, or y squared by b squared will be equal to, I'm multiplying everything by minus 1 both the sides, so that's how this became positive. So when I multiply with minus 1, this becomes positive and this becomes minus negative. So I'm just writing it. Yeah, so far I have done nothing fancy here. I have just tried to simplify it. Okay. So from this, what we get is y square equals, b goes to that side, butterfly multiplies with all the terms. So it becomes b squared by a squared times x squared minus b squared, or y equals square root of up to this much. Okay. I had this equation which I kind of forced you guys to believe that this is the equation for hyperbola, and from that I'm trying to find out this one. Yeah. So far okay. Now comes the thoughtful evaluation of this one. This is where you have to channelize all your neurons to one place. This is here. Now imagine this. I was just a little while ago I was talking about asymptote. This goes as far as you can imagine, depending on how tall the wall is or how wide the wall is. Let's say my hyperbola is aligned like this, and this will this will keep on going along this one, okay? And imagine a situation when I go way too far. I start from bikini and I went all the way till Irving, almost infinity, let's say, on the coordinate plane. When this becomes very, very big, what happens to it? Y? When this becomes very, very big, when x is almost infinity, because it is this guy, hyperbola, is trying to get close to the asymptote, okay? Unfortunately, it is not. It keeps trying hard, keeps moving towards it as much as it can increase the x. And let's say we reach infinity, but it has still not touched the asymptote. Okay? It has just got very, 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 very close to it. Meaning, when x is infinity, what is the impact? What is the relevance of this guy then? When x gets very, very close to infinity, something multiplied with infinity minus something is as good as infinity actually. Yeah? That's why I was saying everybody has to pay or concentrate on the neurons here. Now look at this equation, okay? Sahit here. Don't worry about writing down anything. You have everything for your disposal. Here I'm saying just look at this equation. Stare, stop, whatever you want to do. This equation. Here I'm saying that when my x value is tending to infinity or gets to infinity, an unimaginably huge number, then something multiplied with infinity will be equal to infinity, and infinity minus b square. I don't really care about this b square now. What my x is
the square root of infinity, which is infinity.
Exactly. So this is negligible actually. I can just ignore it. So that means if you look at this, y in the case when we tend to infinity, y will be equal to plus minus square root of b square by a square times x square. I can ignore that at that end point. Or you can also think, okay, I'll come back to this one, okay. So y will be equal to plus minus the square root of the whole thing will be b by a times x. This is your asymptote. This is the slope of the asymptote. This is the line, the two asymptotes that you're talking about. One with a plus sign, one with a minus sign. That is how you guys remember, when you multiply the slope of two perpendicular lines, it gives you minus 1. Yeah? Correct? So, slope of, if somebody's slope is 2, a line perpendicular to that will be having a slope of minus 1 by 2. That is how when you multiply these two, you get a minus 1. Yeah? But even if this is not ringing the bell, forget about it. These are the two asymptotes here. Okay? And when you look at this equation again, this is representing your hyperbola, and which has something getting subtracted from it. That is why your hyperbola never touches the asymptote. Now look at this y value for the asymptote, and here you have the same thing, minus something. That minus something, regardless of how big or small that is what is making sure that your hyperbola never touches the asymptote, just gets very, very close to it but never touches it. Is it relatable so far? Samriddhi, Dev, Praneeth, Vishal? So again, see, I will not leave you guys till I myself get convinced, right, about my own teaching skills. This was the equation for the hyperbola. From that, what we did was, we derived what will be my y value in relation to x, a and b. And then, we are just doing a thoughtful evaluation of this thing. Since this hyperbola doesn't have an endpoint, it can extend as far as we can go. So, we are saying, okay, fine, when my x tends to infinity, what happens to this value or this comparison? When x is infinity, this is negligible. So this part alone becomes my equation for the asymptote. One is this one and the other one is perpendicular to that. So these two are my asymptote. Okay. So one has a positive slope, one has a negative slope. That is how you see it. One with a positive slope, one with a negative slope. Okay. It may or may not be perpendicular. Let's keep aside the perpendicular part here. But one is a positive slope, one is negative slope. So one positive and one negative multiplied gives you a negative. Right? So you have two asymptotes here. Now, when you look at this equation again, you see that okay, this part alone is my. When I'm just looking at the y value of the hyperbola versus the y value of the asymptote, which is a straight line. From the straight line, something is getting minus. That is what is on the hyperbola. Yeah. So far, okay. Now, let's do one more thing. So we looked at one equation. Now I will do a side-by-side comparison so that you guys are more clear about what I'm trying to be myself clear about. Okay. So now everybody can see the full board, right? Full board is visible to you guys, and everything that I'm writing is legible, right? Okay. Now I was kind of telling you guys that my hyperbola can be written in two different ways: x squared by a squared minus y squared by b squared equal to 1, or y squared by b squared minus x squared by a squared equal to 1. These are my two scenarios for the hyperbola. Okay. Now from this one, when my x value was positive, we found that y equals plus minus square root of b squared by a squared times x squared minus b squared, and we said okay, fine. Keep looking at this one. Okay. Now when you look at this equation, do the same thing. What will be the value of y squared by b squared? Let's get it to this point. Okay, will be equal to 1 plus x squared by a squared, or y squared equal to b squared plus b squared by a squared times x squared, or y will be equal to plus minus square root of, I will put this, b squared by a squared x squared plus b squared. I have done nothing. I mean, I have just did the same thing like what we did here. Yeah. So I'm writing this equation here at the top so that we can do some parallel analysis of what we have here. So from the second equation that I'm saying that this is also an equation for the hyperbola, what is my value of y? It becomes plus minus square root of b squared by a squared times x squared plus b squared. Yeah.
So the first one is for horizontal ones, right?
First one is for horizontal, this one is for vertical hyperbola.
Wouldn't a squared and b squared stay this, like switch too then? Certain like they have to, wouldn't they stay in their regular places?
No. So basically what happens is, and again we will decode this, okay? I'm just putting the fact in front of you and we'll analyze this to make our conclusion from this, okay?
Okay.
So I was saying that okay, ellipse is the starting point, and our equation for the hyperbola is an extension of the ellipse formula. When you put a minus in between, you get one hyperbola. I mean, when you put a minus in between, that becomes the equation for the hyperbola. Now, whether x has a minus or y component has a minus, there are two different scenarios. Okay, when this is a scenario, this is the value of y. When this is a scenario, this is the value of y. Now, think about it. Think about it. In this case, I am saying that if this is my asymptote, right? But asymptote is always going to be b by a times x. This is the equation for the asymptote, right? One will be with the plus value, other asymptote will be minus b by a times x. Correct? Here also the same thing. One asymptote will be b by a times x, other one will be b by a times minus x. Yeah. So asymptote will be the same. When you have the equation, your asymptote will be the same. The question is whether the hyperbola is like this or like this. That is what we are trying to figure out. Now, it is going to be a more of an analysis situation. I want you guys to look at the board with your full concentration, okay? Look at, we have the asymptote, okay? We're just trying to figure out whether this is going to be horizontally aligned or vertically aligned. So is the case with this guy. Now look at this situation, okay? What happens when x is 0?
If x is 0, then
Y will be?
look, that means it's a non-real number.
That's what, I'm just coming to that. So you are on money right now. I'm saying when x is 0, what happens here? This becomes minus something square root, and that's an unreal or imaginary number. Meaning, when you have this equation, you cannot have x equal to 0. Meaning, when will x be 0?
Never.
No, when x can be 0? When your hyperbola touches the y-axis, that's the only situation, right? Every point on the y-axis is where you have x equal to 0. But as soon as you put x equal to 0, you get a square root of negative, which is an imaginary situation. That means if you have an equation like this will never be touching any point on the y-axis. That means it has to be horizontally aligned. Again, look at this guy. When x is 0, what's happening here? When x is 0, this part becomes 0, and then you have square root of a positive number. Meaning this is technically possible. You can have a point on the parabola which touches the y-axis. It's not parabola, sorry, hyperbola. Meaning when x is 0, this is a valid scenario. You can get a valid value of y. When x is 0, you can get a valid value of y. And that is, you are only contemplating whether it's horizontally aligned or vertically aligned. In this case, when x was 0, you are getting into an imaginary situation. That means this is not possible. So that means this is horizontally aligned. That means it is not touching the y-axis at all. When you come to this situation, when x is 0, this is still a valid scenario. You can get a square root of a positive number. It's a real number. So that means it is touching the y-axis. When will it touch the y-axis? When it is like this. Like this.
Okay, yeah, that makes sense.
That's why I was saying that next 10 minutes are going to be intense. Now tell me guys, when you looked at, okay, this is a starting point. You have everything in the video. You have everything in the video. What was our starting point? I said x square by a square minus y square. So what starting point was that? Okay, hyperbola is nothing but an extension of my ellipse. So ellipse is x square by a square plus y square by b square equal to 1. That's my equation. Hyperbola, you are flipping sides. So there has to be a negative operand in between. And negative could be against the y term or could be against the x term. So these are the two possible scenarios. From that we found out the value of y. Now we are saying, okay, if I have a minus against the y component of the term, of the equation, is it vertically aligned or horizontally aligned? And we saw that, okay, if y has a negative term, so y has a negative sign to it, or y component has a negative sign to it, that means this is my equation from this one, and it will never touch the y-axis because it can touch the y-axis only when x is 0. There has to be one point on the hyperbola which will satisfy this condition, correct? And then, as soon as I put an x equal to 0, I am talking about imaginary situation, imaginary solution. That means this is not possible. This touching y-axis is imaginary. It could be a dream, but not possible. That means this is not touching the y-axis. So this is not vertically aligned. So this has to be horizontally aligned. When we look at this one, when x is 0, what will happen? Oh, this is perfectly fine. Even if b is 0.000001, I can still get a square root of that. And that will be a real answer, real solution. That means it will touch the y-axis. There is a possible y value of it. One with a positive, one with a negative. It will touch the y-axis at one point, even if it is the vertex on this hyperbola. So Now, okay, let me stop there before I give my expert comment. Are you guys with me so far? Dev, Samriddhi, Vishal, Praneeth, Sahib? Even after break, you are able to follow me so far?
Yeah.
Okay, good. Good. That means I'm not that as bad a teacher as anybody would want it to be. Okay. Yes, Dev.
I'm not able to get confused.
Yeah. Tell me better. You are a little confused?
Yeah, confused on like the last thing you said.
Here, up to here. So, okay, let me repeat everything that I did or said. Okay. First of all, I said my equation for the ellipse is this. Okay, x squared by a square plus y squared by b squared equal to 1. Yeah. When we saw it visually that okay, hyperbola has some bearing with an ellipse. It's like you are cutting the ellipse into two pieces and flipping it in opposite direction. So we said okay, so basically one of the thing becomes negative. So we took the same equation for the ellipse. We said okay, fine. When I put a negative against the term with y squared piece, that is one scenario. When I put a negative against the x squared thing, that is another scenario. So these are two possible scenarios of a hyperbola, right? A possible equation for the hyperbola. Up to that much clear, Dave? Yeah. So once we said okay, these are two equations. Now let's see which equation creates what kind of hyperbola for us. That's what we're trying to decode. We said okay, fine, this is the equation. From this we found the value of y. From this equation also we found the value of y. Now we are trying to derive our interpretation from this whole finding so far. Is it going to be a horizontally aligned hyperbola or a vertically aligned hyperbola? Yeah? And we are just looking at this one. See, ultimately, if you guys remember, right, I keep bugging you guys saying that any equation that you see, be it a linear equation, quadratic equation, or any polynomial, it's nothing but a contract or the agreement between the variables. So here also we have a contract between the variables, saying okay, fine, y is equal to this value. That means y has to have some value depending on the value of x. So in this situation we said okay, fine, what will happen if my x value is 0? If I put x equal to 0, this whole thing becomes, y becomes plus minus square root of 0 times something is 0 minus b square. That is nothing but square root of minus b square. So whatever is the value of b, be it a positive or negative value, I'll multiply that with a minus sign at the end. And eventually this whole thing will be negative. And we are trying to find out the square root of a negative number, which is imaginary in nature. So what we are saying is, oh, if I have an x value as 0, then my y value is imaginary, meaning I cannot have an x value as 0 to get a realistic solution. That means there is not even a single point on the hyperbola where the x is 0. There is not even a single point on the hyperbola with x equal to 0. And that means it has to be horizontally aligned, because if your hyperbola is vertically aligned, there will be at least one point here, one point here, which will cross the y-axis where you will have x value as 0. Does it make sense? Yep. You have raised your hand.
Oh, stretching.
Okay. Okay. Similarly, forget about this for now. Come to this. Okay, this is the equation, second situation, when my x component has a negative sign to it. From that we got this equation, and we are just trying to think that how would my hyperbola be aligned? Is it going to be horizontally aligned along the asymptote or vertically aligned? Now let's look at it. We are just doing a child's play here. We are not thinking big things or not trying to solve that using any intelligence. Very simple thing, okay. This is the equation. What happens when my x value is 0? When my x value is 0, this whole thing becomes 0. So I'm talking y equal to plus minus is square root of b squared. Now b could be a positive number, it could be a negative number. Any which way this whole thing will be positive. So I'm talking about a square root of a positive value, whatever it be, regardless how big or small that is. So, okay, so this is possible. Even if this whole thing comes out to be 0.00000001, the square root of that is also a realistically possible number, right? It's a real number. So that means for x equal to 0, y has a real value. So I can have a coordinate. I can have a coordinate on the hyperbola when x value is 0 and y has some real value. And when is that possible? Only and only when it's vertically aligned. Because we saw if it's horizontally aligned, there is not even a single point on the hyperbola which has x equal to 0. Look at this. You are never getting close to touching x equal to 0. See, okay? Make sense? Everybody? Samriddhi, Praneet, Dev, Vishal, Sahit, Davik, Mr. Biren, everybody clear? Yeah? Okay. So, now here's the conclusion from all that gymnastics we were doing so far. Look at this. What did we see? That when my x coordinate or the x part of the equation of the hyperbola has a positive value, that is aligned along the x-axis. When the y part of the hyperbola equation has a positive value to it, it's aligned along the y-axis.
So,
see, this was horizontally aligned, right? We just saw that.
so if y is positive, then that means that it's vertical, and if y is negative, that means it's horizontal.
Correct.
Okay.
Yeah. So this conclusion will help you secure some solid points or solid numbers in your exam without putting any effort. If you can look at this if you keep this concept with you, okay, you don't really have to solve this problem. You might see you'll be given some equations. Let me just put one of the problem here. One of the problem here, okay. Then you guys will probably believe me. You guys have gotten used to the habit of not believing your teacher unless you are proven, right? And that is how it has to be. Don't take any teacher on his or her face value regardless of age. Let me pick up one problem for you guys and see. I'm just putting one example, okay? I'm still not done with what I have to teach, but I'm just putting one question for you guys. It says, which of the following graphs can represent the hyperbola x squared by 1 minus y squared by 4 equal to 1? And you are given two, 4. Okay, and then I have taken only a printout of. I have only taken a screenshot of only two questions. Okay, I'm not going to. Okay, so this is the equation given to you, okay? And I am saying that these are the two graphs. Which one is the graph for this equation?
Is that a 4 underneath the y?
Yeah, 4. And there will be other two problems also, two other graphs like this also.
Huh.
Okay. So there are 4 graphs. This is 1, this is 2, this is 3, and this is 4.
Okay, so between only 3 and 4.
And for me, this is the easiest problem. This one you can solve in 20 seconds if I did a decent job. I mean, of course, after my job, you guys have to do some practice. Yeah.
Is it 1?
Yeah, I got 1 too.
You want to go to 1?
Yeah.
This one?
Yeah.
Okay.
It's either 1 or 2, but I think it's 1.
Let me
Okay.
do something real quick.
But no.
Samriddhi, Vishal, Praneeth, Dev, any idea which option you are leaning towards? What I'm saying is this is a 20 to 30 second problem. This could be a high scoring one if we get the concept right.
I'm between 1 and 2. I'm still thinking.
1 and 2, okay. How about Praneeth?
Same 1 and 2.
1 and 2. Problem is you'll get only one option.
Wait, you can choose more than 1 answer?
Yeah, it has to be one answer only, right?
Only 1 answer?
Yeah.
Oh, no.
Yeah, 1?
Yeah.
Okay.
I want to say 1, but something is telling me. I have a feeling.
Okay. Let me, Vishal, do you want to give it a try, beta? At least reserve your option. Or Dev,
That's right. 2.
you're thinking 2?
Yeah.
Okay. Now, okay, let me bug you guys a little bit. Tell me, Samriddhi, why you think, I mean, how you are kind of nail it down to whichever option is coming to your mind? What went through your thought process?
The formula, I remember like there were 2 different formulas, and the formula that the question provided matches like with the example you showed. So that's why I was able to know it's not 3 or 4.
Uh-huh. Your x value is positive. Okay, so let me first decode it for you guys. What we saw was, first conclusion that we drew from the whole exercise was that if my x component is positive, that means it's aligned along the x-axis. So that's why these 2 are not the option. So 3 and 4 are ruled out. Now we are coming to this or this. If you look at these 2 things carefully, okay?
Pretty sure it's the second.
Okay, Sahit, everybody here. Now, see, 3 and 4 we ruled out with our first understanding, okay? Just by looking at the equation. Now between these 2, 5 years ago, I had told everybody, before you guys had joined, that any equation that you have is nothing but a contract between the variables, meaning any point you pick up on that graph will satisfy this condition. We're talking about this point. If this point is satisfying this condition, then this is right. If this point is satisfying this condition, then this is right. Let's look at one other point. What happens if I put here on this point? If I look at this point, here my y value is 0. Okay? If I put y equal to 0, what happens? X squared by 1 minus 0 by 4 equal to 1.
So x squared by 1 equals to. So x squared equals to 1.
1.
Wait a second.
X equals 1.
Wait, that means one of the roots. So that means it's none of them.
So let me see if this was 1 or 2. Let me check.
So it's none of them.
Okay. So the other picture. So I just took two of the images. Okay. There were 2 more options. So here, this will not be the option. So again, what I'm telling you guys, I mean, again, I jumped onto this problem before concluding everything. But ultimately, how you will solve this is, first is by looking at this graph, you'll figure out what all options you will rule out. These 2 I put them. Okay, I have not taken a printout. If you look at the question also, you'll not find the other 2 options. Okay, I did not take a picture of that. But what I'm saying is, you will first rule out by looking at the equation itself, and then you will see that okay, if these are 2 options, the equation will satisfy this point. The x and y value of this point will satisfy this equation as well. So you know the value of y here, you know the value of x also here. Put the value of y here and see if that is matching with the value of x or not. As simple as that. So this thing should not take much time is what I am trying to say. Provided we are thorough with the concept part of it. Yeah? Praneeth, Samriddhi, Dev, Vishal, did I explain it okay or I got you guys more confused? No? Okay, good.
Yeah.
So again, I remember right when I was trying to start this topic for you guys, right? Conic sections. I was wondering, like, is it going to be a roller coaster for everybody or not? But when I started decoding the topics one by one and we started relating it with the concepts, we see that these are not something that is way too complicated. Actually, it's up to us how we envision them, how do we break it down, use some easy, dirty, nice, acceptable, non-acceptable methods, and we decode it for building our own understanding out of it. Okay, there is no book that will tell us everything that we need to learn. Right? We are taking some concepts, breaking it down. So all that initial 15-20 minutes that I was spending looking at this equation, comparing that with the ellipse, then comparing that with the circle formula, and then kind of deriving some interpretation from that. Some of the things you'll find in the book, some of the things I kind of interpreted by going through it and then tried stitching a story for you guys. Okay? So same way, I would want you guys to practice enough problems after the class also, so that at least you get this as easy to you as possible. Okay? Otherwise, no matter what we do in the class alone, without practice, it might not stay for long. But the concept is very simple. Okay, I mean the equation by looking at the equation itself, you'll be able to figure out what are the options that you want to eliminate, what you want to keep, and then plug in the basic concept. This is the equation for the hyperbola. Any point that I'm talking about has to satisfy this condition. Plug in the value and see, is it aligning with that or not? Yeah? Alright, it's got a bug bite. Alright, so this is on hyperbola. And we have not done any practice. We'll do more practice with these problems in the next class. But let's look at some more concepts relating to what we already know. So there's another thing with respect to foci that we need to talk about. Do you guys remember what is a foci when it comes to ellipse? Foci. Focus point.
Didn't we do that last class?
Yeah?
It's the like middle parts of the major.
Yeah. Not middle part, but it's along the major radius. Yeah.
Points along the major radius. Right?
Yeah.
Do you come up
Does anybody remember or recall what is a foci? Praneeth, Dev, Vishal, Samriddhi.
Isn't it like this thing where if you choose a point along the circumference, the length from that point and then 2 points chosen on the major radius will be equivalent to 2 times the major radius, or?
Bingo. Yep. You are 90%, 95% close to how I would have wanted it to be. So yeah. So foci in case of ellipse, what it says, it's more of a property which says foci are the focal points are along the major radius of the ellipse where this distance and this distance are same. It's a symmetric point.
Okay, so the points along the major radius where the distance from the the roots
Yeah.
of the ellipse
are the same, and the beauty of these 2 points is like that if you join any point along the perimeter of the ellipse and look at this distance d1 and d2, d1 plus d2 will be equal to 2 times the major radius. If you pick another point and try connecting these 2 points, let's say this is d3 and this is d4, d3 plus d4 will also be equal to 2 times a. Okay, and this distance, the focal length from the origin to the first focal point or any other focal point is equal to square root of a square minus b square. We have done that in the previous classes. If anybody is failing to recall, just watch the video of the previous class. I'll get one extra view. But my view is of no use, okay? It's worthless. But it'll be, at least it will help you recall or relate to the concept that I'm talking about, okay? I mean, whenever a new student is trying to join, and when I talk to the parents, they say, okay, subscribe my channel and so that you get access to all this. It gives me a guilt feeling that people will think that, okay, I'm trying to promote a YouTube channel. I have to shamelessly acknowledge that, okay, don't worry, I don't have a lot of subscribers. I have only 1,200 or 300 people subscribing my channel. 100 of them are my family members, and remaining are my students here and the students in India whom I teach. So don't look at me like a YouTuber. I'm happy being a teacher, but when I say go to the video, watch it, you will be able to relate to this concept and recollect it back. Now, what I was trying to say was, like in the ellipse you have the foci concept, same thing applies in hyperbola also. If you have a hyperbola along the horizontal axis or a horizontal hyperbola, whatever you call it, you will have the foci concept here also. There are two focal points along the major radius such that, and if you pick up any point along any of the point of the hyperbola, let's say this one is B1 and this one is D2. The difference between the two is fixed, and that is 2a. Okay, 2 times the minor radius. Yes, Vishal.
A is the minor radius, right?
Major radius.
What's B is the minor?
B is the minor radius, yeah. Or think of it this way: in the case of a hyperbola, whatever is the denominator for the x square, that's what you're talking about. For a horizontal one. If you're talking about a vertically aligned hyperbola, then you're talking about the distance between the two, difference between the two will be equal to 2b. Yeah.
Okay. Yeah.
So again, we don't have much time to deliberate this one in today's class, but what I was saying was, like we have a foci concept in case of ellipse, where any point along the perimeter of the ellipse, if you sum up the distance from the foci to that point, sum of it will always be equal to 2a, 2 times the major radius. Here also you have the same concept, but here we don't talk about the sum of the distance, we talk about the difference of the distance. And here I have put a mod sign. I'm talking about the absolute value of the difference in the distance, okay? Will be equal to 2a. And a is again the a part, meaning I'm talking about this distance, here to here, from origin to the vertex. Yeah? If it is vertically aligned, I'm talking about origin to here. This is my b, and this will be equal to 2 times the b. Yeah? Alright. With that being said, I will leave you guys here and let you guys go through the video of this class and try wrapping your head around this with respect to how the hyperbola came into existence, what is the relationship between the equation for circle, ellipse and hyperbola, how do you recognize the difference between the horizontally aligned hyperbola versus the vertically aligned hyperbola. Just by looking at the equation, how you can derive it, and 60% of the times you will get questions like, okay, this is the equation of the hyperbola, tell me which graph is mapping to that. Or it would be, okay, this is the equation, graph the hyperbola. These are two varieties of hyperbola that you'll question that you'll deal with, apart from the foci concept that we just started talking about. So in the next class we'll conclude the foci concept and then muddle the water a little bit, solve 5, 6, 7 problems in the class together, so that if there is something that is ambiguous, that gets exposed and knocked off in the next class. Yep. Is that okay? Alright, so I'll let you guys go. Enjoy the rest of your evening and wait for the video and then what will do it for. Alright?